Welcome to Computer Vision Streams. I'm your host Anton, and today we continue to explore DeepStream Python sample applications. In this video, we will discover DeepStream test1 application and DeepStream test2 application and how to rewrite them in a more Pythonic, readable, deployable way. Let's start with DeepStream test1 application. Simple example of how to use DeepStream elements for a single H.264 stream, starting with file source, decoding of the streams, and the stream moves to create a batch for DeepStream elements, and the infer element for primary inference of object detector. Then we have NVIDIA SOSD and the renderer to output images with bounding boxes. Let's open two of our application. First one is the rewritten version in a more Pythonic way, and second one is the default DeepStream test1 application. We see that the rewritten version has 70 strings more, and it will be much more readable. We will see it later. Before that, let's try to run both applications to confirm that they produce the same result. To run DeepStream test application 1, we need to create a Docker file with all the dependencies. We use GStreamer Python and DeepStream Python bindings. You can check out previous video to understand how to create this Docker file. Here, I just opened this container, and we can go to the folder of DeepStream test1 application and run it with a sample H.264 stream provided by original DeepStream application. After a couple of minutes, your inference engine will be built, and you will see the same result with bounding boxes and with a probe showing some meta information. Now let's go to workspace directory with my Pythonic samples, and we can run the same application but with rewritten Pythonic version. It will also take some time to create an engine, and you will see the same detections with the same information about metadata. Let's see how pipelines are created in the DeepStream test1 application. So DeepStream test1 application shows you how to create pipeline manually in a GStreamer way, where you will try to create all elements. Then you will try to capture all the errors if this element could not be created, or if this element is not available on the platform. For example, you forgot to upload to install some plugin, or you just misnamed this plugin. Then after all the elements in the pipeline are created, so it even might be difficult to see in one window what are the elements of the pipeline without printing the whole pipeline with additional functions. Then we also have a couple of conditions depending on the platform where you want to output and which element you will be using that should work on the target platform. After that, you have a couple of conditions to set parameters of your different elements. And it could be width and height of DeepStream MOOCs, or it could be a configuration file path for NVIDIA. Next, you need to invoke pipeline add to add all the different elements that you created to the pipeline bin. And you need to write the same amount, or sometimes even more, lines of code to correctly link all the elements. And here you see that we have some special dynamic link where you need to create paths manually and to connect decoder and NVStream8. We will see how we can make it simpler. After we connected all the elements in a correct way, we can start our our main loop of GStreamer library, but this part of the code will be exactly the same in a Pythonic way as well. So let's see how we can improve or simplify pipeline creation part. Our main goal is to use GST parse launch function, and GST parse launch function works similar to GST launch function, where we can describe our pipeline in one string. And in Python, it's very useful because we can easily use formatted strings to parameterize all the settings that we would like to have. Here, the advantage of this approach is that we write less code. It's GST parse launch that is responsible for correctly adding and linking our elements. And if you are worried that you are afraid that you will not have the correct errors, you can always use GST debug equals to level at least 3 or even more to see very good error messaging from GStreamer that will show you exactly which element GST parse launch was not able to connect and what were the problem. Maybe it was the name of the plugin, maybe it was the settings that is not supported or does not exist. So you should not be afraid to not handling every error after creation of every small element. So here the trick that you need to know in order to implement DeepStream test1 application in Python is to understand how to connect paths from NVIDIA decoder to StreamMux. For that, we create StreamMux with a name, StreamMux Muxer, and we output our NVIDIA decoder to specific path of StreamMuxer. Here in this example, because we have only one input stream, it will be sync 0. In the later videos, we will see how to parameterize and how to use multiple sources. Another advantage of this approach, actually there are two advantages of this approach. First, everyone who reads your code, it will see exactly what the pipeline is running in a linear way, and there will be no questions of you will don't need to spend time reconstructing the whole pipeline and to have exchange with other developers if you are analyzing this pipeline the first time. Second advantage is that this pipeline, if it's simple enough, you can run with GST launch. And sometimes it could be useful if you have source elements that are more complicated and require maybe some additional plugins for pre-processing, or maybe you have a connection with industrial cameras that require some specific parameters transmitted for it to work properly, and you can just copy-paste this string to GST launch and make faster iteration to debug the whole pipeline in comparison to basically recreate this string from a lot of lines of code manually. In this part, we covered the creation of the pipeline. Next, we have exactly the same code, except for this line where in original version we already have an object of our element where we want to add our pad, our probe, but here we can retrieve this element from our pipeline with a function get by name, and we will use the name of this element. And you can have access to all the elements to modify the config after pipeline creation or to add probes to retrieve the meta information. Let's compare how we can improve the code of our probes. So the code of the probe you cannot improve that considerably in comparison to pipeline creation. There is no easy trick. Here, one observation is that um, a lot of DeepStream test applications, they were translated from C, C++ test applications. And here you can see that with direct translation from C, where sometimes we declare all the variables at the beginning of the probe. In the Python, we don't need to do that. We can declare those variables at the moment where we will use them, or we can just avoid using those variables at all and directly use format strings and the value that we can get from the frame method. Another observation that there was no return value in this line, but it will not. It's not a problem. Next, we retrieve batch metadata. It is very similar, and here it will be a little bit specific to how we work with metadata in DeepStream Python applications. We need to make these iterations through frame meta list object. But for every object, we need to invoke this special cast function. Here you see the explanation, but short explanation would be that we need to keep memory management on a C level, so we use this special function to avoid Python garbage collection and keep ownership in the underlying C code. But you see here we had to use try except logic, and then we use try except logic at the beginning when we try to get the new frame metadata. So this is a good use case to introduce the function that will iterate through this list, and it will yield data and catch this stop iteration and make a cast for a specific type that we want. And then we can just use for cycle with our list and the metadata, frame metadata, or object metadata to be able to perform correct cast. After that, the functionality is exactly the same, but I removed the usage of these variables. So here it's a little bit in a C way. When we declare the variables at the beginning and initialize them, then we get the values in the middle of the function, and then we use format function in this way. Here I prefer to use f-strings of the latest Python, but other code stays the same. Which is a couple of lines more clear and maybe more readable. And also small change. By default, all the sample applications they should be run from the sample applications directory, and it considers a lot of common libraries and additional libraries in the relative path in the parent directory. I prefer to keep the code of my applications in completely different directories, and if there are some dependencies on DeepStream or on DeepStream Python applications, I will just try to link them or to add to Python path those folders separately. But all my dependencies of my applications, I will keep them in another folder that makes my code more flexible. I hope you find this transformation of DeepStream test application useful, and we will see DeepStream test application 2 in the next video.